I made a game in 3 hours, and today I'm going to show you how you can do that too. It's a very simple holiday themed game, but as you can see, this game is based on a maze where you're searching through these long corridors of presents looking for the table of cookies. And once you find the table of cookies, there it is. The maze shrinks down to the snow, regenerates, and comes back up again, and you start over. The entire maze is randomly generated each time, and we're going to get into the code that makes that happen. First, let me give you a quick rundown of the components in the game. So, I have my spawn point. That's usually always in every game, right? Here's my cookie table. It is nothing special. It is a bunch of rectangular parts put together and some cylinders. I have two different walls. You'll see here, there is this one called side wall, and then there's this other one called front wall. I could have used the same wall, but I wanted to have a little bit more variation in what you see, the present layout, so they each have their own unique layout. The presents are merely rectangles, so they're just a part welded to the wall. The wall's primary part is set to the sidewall primary part in this case, which is just the part that makes up the green background. That'll come important whenever we look at the code. A few other random pieces here is we have this end part, which is in an invisible space that is set to my grid size of 10 by 10 with a height of 1, and that gets placed where the cookie table will go. And we have this path piece, which is what colors the path as you walk through the maze in order to see where you've been. All right, let's get into the script. This is a single script game. It was done very quickly, so the code may not be the cleanest. So first we have a bunch of constants. Important ones here are the size for the X and Z. If I want a big complex maze, I can put this up to something like 16. If I wanted simple, 8. I can go as high or low as I want. The only limitation is the higher and higher you go, the more and more walls, and therefore the more and more time it will take to load. So here are the two front wall and side wall parts that we get out of the workspace, and we parent them to nil so that they disappear from the workspace. Similarly with the path part. We make a new folder where we're going to put all of the actual walls for the maze. And so here's where we make the walls. This function just goes through and fills out a two-dimensional table with the walls needed for each cell. Each cell has a left, a right, a front, and a back, as well as a path part. We make up all these parts by cloning our side walls and our front walls and adding them to this two-dimensional array, and therefore all of the walls will exist in the workspace. When we don't need the walls, they will be moved down into the ground. Then we have map data. So when we want to reset the map, we have two arrays that are important. The content, which is a two-dimensional array where, again, we have a left, right, front, back, and floor. The left, right, front, and back all have possible values of either wall or blank. Now, if I want to show you quickly what it would look like if I don't actually create the maze, come here in the create maze and comment out the line that's actually going to do the randomization and run the game. From here, you'll be able to see what the completed from here you'll be able to see what the maze would look like without any paths. So as you can see, I have these 10 by 10 cells, and each cell, if I zoom in on one, has a front wall, a left wall, a back wall, which is also the front wall of the next cell, and a right wall. So that is what we get set up from the make walls and the reset map. Now, the fun part. How do we actually randomize the map and create the maze? For this, you have to understand a basic concept of depth first search. Here's a simple binary tree where each node has two connections and it walks down. Notice that they're numbered in what's called breadth first search, where at each level they get numbered along. So as you go deeper in, it goes deeper this way and deeper that way. And then it goes to the next level across both of those. Depth first search is the opposite. Depth first search would start at 1, go to 2, and then it would choose to go to 4, and then 8, 16. And there's no place else to go. It would start walking back up until the next place it finds where there's a choice. So then it would come down here to 17. Then it walks back up and then sees there's another choice here and goes to 9 and then 18. Walks back up, etc., until it visits the entire tree. And this is the same algorithm used for the maze. So we pick a random starting point and we pick a random ending point for where the cookies will be. And with the starting point, we pass in the map content that we initialized up here. And I forgot to mention that there's also a visited two-dimensional array, which indicates whether or not a particular square of the grid has been visited by the algorithm. So we go into this randomized DFS function. We mark the vertex that we're at as visited by setting its value to true. We find one of its random neighbors that is not visited. So to find the random neighbors, we look at whether it's on the edge of the grid, being greater than 1 or less than the size. And if it is, then we can also see, has it been visited? And if it hasn't been visited, it gets added to this available table. In the end, if we have any that are available, we pick a random one out of them. Otherwise, we return nil. If we return nil, then next will be nil, and so we won't continue, and that means we reach the bottom of this particular leg of the tree. Once we have a random neighbor, we connect that vertex with that random neighbor, which goes in to connect. It just looks at are the x's different or the y's different, and it either fills in the left wall of one cell and the right wall of the other as being blank, or vice versa. Or if the x's are different and the y's are the same, then it'll do front and back. And it makes sense in that when you're looking at the grid, the back of one cell is the front of the next cell, or similarly, the left of one cell is the right side of the other cell. And by marking these blank, we know that those walls don't need to be there. Then we just recursively call this randomized DFS function again, which goes through the same process, which is in essence walking one layer deeper into the tree. Once this randomized returns, that means we went as deep as we could, and we look to see if there's a different path from this particular vertex. And if there is, then it repeats. If not, then we return, which will go up one layer of this random DFS until we get back to the very beginning with no more paths to be covered. The benefit of this algorithm is that it always uses every cell in your grid. So there's never a place where you can't reach from the starting point. It's great for generating levels and worlds and games in general, not just mazes. All right. So then just some cleanup work here where we make sure we set the floors properly to the start and end in this map content, because that is our data about the map. And that's how the maze gets created. And then how's the game work itself? So we have a while true do loop, which just runs indefinitely. Each time we reset the map, we create a new maze. We teleport all of the players to the starting point using pivot 2 on their character. We have them all anchored so that they can't move until the map is ready. And then we go through and set up the actual walls. So this is where the rendering happens. We use our map content, which is the randomized map, and we look at whether the left walls, the right wall, the front and the back is set to wall. Remember, we set some to blank whenever we wanted to connect them. If it's set to wall, then we add the particular walls that we generated into this parts array. And you'll see why we do that in a moment. If it's the starting point, we make sure we pivot the spawn point over to the start. And that way, if people join while a maze is active, they will all spawn in the proper spot. If it's an endpoint, we pivot our transparent end part over there. And this is so that we can set up a touch point and we know when a character gets to that point. We also pivot our cookies over to that same point so that the users can see where they want to finish the map. The next thing is we use the tween service on a number value instance, which it's always very important. That number value must be parented somewhere inside the workspace or else it's not going to tween. The tween service will allow us to change the value of this number value gradually from 0 to our target of 1. We can attach a changed event function to this number value so that as the tween service changes its value, we are able to go through that table of parts of all the walls and pivot them upwards. And that gives us the ability to move all the walls up and down between rounds, give that neat little effect whenever somebody completes the maze. We play the tween, and once it completes, the walls are in place, so then we can go through and unanchor all the players and they can start running around. We wait for a winner, and then we play a reverse tween, which just brings the walls back down. We clean up our touched event, and then the whole loop starts back over by resetting the map and creating a new. And that's it. That's the end of the scripting. There's a few other things that I added in this 3-hour game is a simple starter screen GUI that gives us our abilities. And so whenever you find the cookies, the reward is you get faster walk speed. And so there is a simple text display for the walk speed and the number of cookies you've ate. This local script gets those text values, waits for the character to exist, finds a humanoid, subscribes to the changed event, gets if the walk speed changes and updates the cookies value as well. Very simple for the UI. And just to make it a little more festive, there's a starter character who gets a custom drawn clothing to make them look like they're in the holiday spirit. I hope you enjoyed this video. If you want to see more stuff like this, please comment, like, and subscribe.